I want to talk about kind of rules of exponents, but in particular when we take something to the 0 power. If I have 3 to the 0 power, you're going to see that this is the same as, let's say I have 3 to the third divided by 3 to the third. That's equal to 3 to the 3 minus 3 power, because this is in the denominator. And this is then 3 to the 0 power, which is, well, 3 cubed is 27. Bottom, 27. 27 over 27 is 1. And so we have defined anything to the 0 power as equal to 1. If you have 1,000,000 to the 0 power, it's equal to 1. And you're going to see this in your exponential curve, that it doesn't matter what your exponent is, or I'm sorry, what your base is. If it's e, if it's a 100, you're always going to see this line go through whatever your base is, say b, but it's going to go, the y-coordinate is always going to be 1. Sorry, doesn't matter what your base is, when you're always going to go through 0, 1 when you have your exponent. You can check this on Desmos, but really the better thing to do is just realize what I showed you with the 3 cubed over 3 cubed. It's going to be a 0 exponent. All leading up to what I want to ask you, what do you think about 0 to the 0 power? Well, if you think about 0 squared, that's equal to 0 times 0, which is 0. 0 to the 10th power is 0 times 0 times 0 times 0 times 0, and that's always going to be 0. So it kind of makes sense that you would think, okay, well, 0 to the 0 power, it's just another exponent, it's probably going to be 0. But then again, you have me telling you that any number x to the 0 power is 1. Doesn't matter what x is, something to the 0 power is 1. And so you may be thinking, And I must confess that this little video that I'm doing is taken from somebody who just did a masterful job of this. But I want to go ahead and follow up in his footsteps, and what I want to do is say, well, we know that 1 to the 1 power is 1. I want to look at f of x equal x to the x power. If x is 1, the exponent is 1. If x is 2, the exponent is 2, and f of x is 2 squared, which is 4. If x is 3, 3 to the third, 3 cubed, 3 times 3 times 3 is 27, and so on. Let's look at, as we go down, 0.9 to the 0.9 power, 0.8 to the 0.8 power, 0.7 to the 0.7 power, 0.6 to the 0.6 power. What I am doing graphically is I am approaching 0 from the right. This is called limit. You're going to see this a lot in calculus. You're going to see it a lot further on. The concept of limit of infinitesimals as we get very close to some number is what calculus is all about. So let's just keep going. 0.5 to the 0.5, 0.4 to the 0.4, 0.3 to the 0.3, 0.2 to the 0.2, 0.1 to the 0.1, and let's see what we get. Equals, 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 equals. Because my camera is my phone, I had to do this ahead of time. I've got these all here on my little cheat sheet. 0.9 to the 0.9 is 0.909. 0.8 to the 0.8 is 0.837. Kind of looks like we're going towards 0, doesn't it? We're certainly less than 1. We're not moving towards 1. 0.7 to the 0.7 is 0.779. 0.6 to the 0.6, 0.736. Now I'm starting to wonder what's going on, because we're not really getting close to 0. We're getting smaller, but it doesn't seem like we're getting close to what I think we ought to be getting to. 0.5 to the 0.5, 0.707. 0.4 to the 0.4693. 0.3 to the 0.3 is 0.696. Now, by the way, I should say there are plenty of other decimal places, but I'm limiting it to 3. All of a sudden, though, with 0.3 to 0.3, I'm getting bigger. I'm not heading towards 0 like I thought. All of a sudden, I'm heading back. 0.2 to the 0.2, I'm getting bigger again, 725. 0.1 to the 0.1, 0.794. Now let's get really close. Let's go 0.01 to the 0.01 power. That's 0.955. This is kind of getting close to 1. 0.001 to the 0.0001 power. That's 0.999. It looks like 1 is where I'm heading. If I go, and I did with 9 zeros, 0.00000000001 to the 0.00000000001 power, I get 0.9999999. I get like a lot of 9s in there. So it looks like, and I'm going to write this as the limit as x goes to 0 of x to the x is indeed 1. That means as I get really close to 0, my limit gets really, or my function value gets very, very close to 1. In fact, if you graph this thing, two to the squared power is going to be 4. 1 to the first power is going to be 1. It just kind of does this, and then all of a sudden it goes like we saw here. It starts curving, but then around here it comes back and hits this point right here. You can check this out on Desmos. Just type f of x equals x to the x. And you're going to see this cane-shaped function. It's almost as if the designer of mathematics was saying, well, yeah, we should go here, but oh no, we can't have 0 to the 0 be 0. We need to curve back up and make it 1. Very interesting. Hope you've enjoyed this.